Mm. Okay, hello. So this is the one of the most unanswered question of ultrasound from A level physics. So this question is of Classme book. Uh, I guess page number. Let me. So page number. This is of page number 253. There you will find out this question also. So actually I tried this question for about 15 hours. So after 15 hours I get the clear concept of this question and what this question is asking about. So I'll discuss this question. So first, what is asked here? So what is given? The specific acoustic impedance of fat, muscle and bone are this 1.4 into 10 to the power 6, 1.6 into 10 to the power 6, and 6.5 into 10 to the power 6. So these are the specific acoustic impedance that you know. This is Z. Let's say this is Z1 and this is Z2. Okay, so this is Z2 and respectively. Okay, the linear absorption coefficient in fat and muscles are 0.24 and 0.23. So these are the mu. You know the mu. This is the linear uh, absorption coefficient. We can also say it is mu, or sometimes it is also written as k in some books. So you can just remember is at u mu. So we have so the linear absorption coefficient are uh, fat and muscles. So these are given here. So what actually question is asking us? So a parallel beam of ultrasound of intensity I is incident on the layer of fat. So this intensity I is incident on the layer of fat. So discuss quantitatively in terms of I, the reflection and transmission. You have to discuss it, like you have to answer the reflection and transmission of the beam of ultrasound as it passes, where it is passes through the layer of fat, thickness the 4.0 mm, into the muscles, thickness 4.35 mm, and finally into bone. So so what question is asking, that you have to find out the both reflection and transmission that is passes to the fat, having thickness 4.0 millimeter, and also passes to the muscles and bone into finally into bone. So I'll just show you the so wait for a minute, let me clear this all. It will take a long time, like when I took a long time. Okay, so this is the fat. Finally this is the fat. So this is the fat. Okay, this is the fat and this is the muscle. So it will be easy, you know. Last time what I did, that I just sketch figure like this, you know. So don't sketch figure like this. It will be far more better to create figure like this. You'll get more understanding while sketching this kind of figure in exam also. So this is the actual diagram of fat, muscles and bone. So here you have fat, muscles and bone. So what happened at first, as asked in question, incident on layer of fat is I. Okay, and transmitted in fat or incident at fat muscles boundary. So this is the fat muscles boundary. Do not get confused. This is the fat muscle boundary and it is incident. Okay, so it is incident here. So it is incident here and this is the fat muscles boundary. So this is a fat muscle boundary. So it is incident here and it is transmitted into fat. So this is the fat and it is transmitted over here. Do not get confused, because I also get a lot of confused while solving this question. and this is the reflected out of fat. So this is reflected IR, it is reflected out of fat, it is like out of body. So let's move the actual reality of question. So what this question is asking us to calculate the reflection and transmission. So at first you need to do not go inside, just go at surface. So just see there is fat and there is an incident ray passing into fat. Okay, so this is the actual steps. So incident into fat, muscles boundary, or transmitted at layer of fat. So in that figure, here is so this is fat, and here is one muscle. So here is one muscle. So this is the eye over here, and this is the IT. This is the IT, and this is the IT. So you have to find out the transmitted. No, this is transmitted. Okay, so transmitted at fat layer, that is IT equals to I e to the power minus mu x 0.24. It is the linear absorption coefficient of fat, and the thickness of fat, the thickness of fat is 4.0 mm. Okay, so here this is the fat, this is the muscle, and this is the bone. So this is the next step. So next step, transmitted in fat or incident at fat muscle boundary. I talked to you in previous one. Okay, so I said that IT is the transmitted in fat, and this IT1 is transmitted in muscle or incident at muscle bone boundary. So actually what happened in many layers, that we have only done a lot of question of 2 layers. So while solving while solving of 3 layers, we get more confused in incident and transmitted. So do not get confused in incident and transmitted. So transmitted means this is the muscles, and IT is ultrasound wave is transmitted over here, but this is incident at muscles bone boundary. So this is the muscles bone boundary, and this is the reflected at muscle fat muscle. So this is the here is there is a fat muscle, so fat muscle boundary, this is reflected at fat muscle boundary. So this we already did it before. So this is the incident into fat, so we'll be calculating the reflected into fat muscle boundary. So this is the reflected at fat muscle boundary, that is IR. So so let's do. So this is the fat here, and this is the muscle. Okay, so this is the muscle, so this is the muscle. So so this is the incident into fat, this is IT, this is IT, and this is reflected. This is reflected, this is reflected means IR1, and here one goes, that is so look here. So many students did mistake here, that what they do is that they just put some values and they get mistake answers. So here you have to do the fraction of incidence. So this is the fraction of reflection. Okay, so this is the IR over IT. You'll get it this value, and IR is IT. Okay, so 4.44 into 10 to the power minus 3. So we know that this is transmitted in fat or incident and fat muscle boundary, and also so this is the transmitted in muscles or incident at muscle bone boundary. So this is the muscle bone boundary, do not get confused. So this is the reflected at fat muscles, and this is the IT, this is IT equals to IT. So this is IT1 and this is IT1 and this is R1. So so how you can do this? We know that this incident ray is equals to sum of reflected, the sum of transmitted and reflected. So this is the reflected. So so to calculate this IT, this is IT1. So to calculate IT1, you can just do IT minus IR1. So this is this. Okay. So here we got the incident into fat and we also got this. And so here, okay, the transmitted into muscles or incident at muscle bone boundary. So again I draw this. So this is fat, our fat, and this is our muscle, and this, and here we have bone. Okay, so here we have bone. So this is I and this is IT, you know, and here we have one what called IR1. Okay, here we have IR1 and here we go one, this is IT, what called this is IT, this IT1. Okay, IT1. So this is IT1 and here also one reflected, that is IR2. Okay, IR2. Okay, IR2 or IR1, IR2. Okay, so IR2, let's say. Okay, so here what happened, that transmitted into muscles or incident at muscle bone boundary. So this is the muscle bone boundary, so IT1 is the incident. Okay, and to calculate IT1, you can simply do IT. This is from here. Okay, so this is R1 and this is IT. So IT equals to IT minus IR1. So what I did here is I just put this IT value over here and this value. Okay, not this value here, and again we have IT and I just place this, and finally I got this 0.904, that is incident at muscle bone boundary. So this is the previous diagram. So here, so why I did again this incident into bone, that what happened, it, so in so many layers attenuation process occurs. So in two layer you don't have to go like this, but while solving of three layer you have to do this incident into bone again one. So this is not equals to this. Remember, this IT1 seems like I1. I also got difficult with this, and I feel like my teacher teaches a wrong idea. But but when I solved this question after investing my these 20 hours, I knew that this is different. So it is different. So this is not equal to this, because some waves gets echo and some wave reflected and some gets attenuation. So again you have to find out this I1 and this is I2, which is transmitted into bone, that, and this is reflected at muscle bone boundary. So here this is muscle bone boundary. I told you this is muscle bone boundary, and we got this incident into bone. This so incident into bone or transmitted at bone. Okay, so again, so first I'll make this bone, my bone, and here I have one. This is what go here, and here I have this incident. This is I1. So I1, and here I have my muscles, large muscles. a large muscle which is which have thickness 0. This with attenuation 0.4, and also I have thickness is 4.35. You can convert into centimeter, you'll get 4.35. So 4.35, and I calculated incident into bone. So this IT1, here I have IT1, IT1, okay, IT1, no, here I have IT1. I told you IT1, IT1. So IT1 0.904 I times this. Okay, so let's move to another step. So in another steps, we already know this is the actual diagram of how ultrasound waves gets reflected and transmitted into 3 layers. And also you have to know these important things. This in 3 layers, one incident occurs and one transmitted occurs. Okay, this I knew by solving this equation. So here we go. So we had already calculated the incident into bone, so no need to be serious about it. So here, so this is the final steps. So in final steps, this reflected. So I'll again draw. So I'll draw my bone here, my bone, my small bone, and then after I will draw this my muscles. So I know here some IT. So IT1, and here is I1. Okay, I1, and this is I2. I got this is I. This is incident. Okay, no, not now. So I'll just do what here is so here's some reflected IR2, as you can see into figure, or just you can reverse this video and see it properly. So we have acoustic impedance here of bone, so of muscles, and here we have fat. So we have fat. So this is our IR2, and this is IT1. Okay, and you can get this value by solving. And for IR2, I just put this IT1 value here, which I got. This is I1. Okay, this is I1. Sorry, this is I1, and this is also the I1. So I1, and I got this I, and then finally transmitted into bone. So here is transmitted into bone. So transmit IT2. So an IT2 equals to IT1 minus IR2, that you already know that. So 0.332 minus 0.122, you will get this final answer. So these are the final answers. So I suggest you to review this like watch these videos again. So if you watch this video again for twice, then only you understand this question. Otherwise it will be very hard for you to understand this question, because if you able to solve this question, then you won't get any difficulties to solve all question of ultrasound. So this is the one of the most important question of ultrasound in A-level physics. So there are at first it will be very difficult and confusing for you, but when you solve it for 5 to 6 times, then you'll know the actual meaning what this question is asking for us. Okay, so thank you. So do this, revise this, subscribe my channel too. I'm uploading this kind of question and also solution. Okay, bye bye.